Hello, everybody. Thank you for joining the webinar today for Knime Edge and Data Apps. I think today should be a really cool session for all the partners as we can go through some of the new functionality that's come out with Knime and how it's relevant for partners to help jump into new markets and opportunities. Before we start, if anyone has any questions, there should be a Q&A section you can use. We have 3 panelists today. Whoever is not presenting will be monitoring the Q&A section. And also at the end, we will have a lot of time for Q&A if you want to ask directly. This session will be recorded and will be shared with you all after the webinar. It should also be available on the partner portal on our website. And if anyone has issues with the Q&A, you should see it at the bottom of your screen here. We'll have some questions. They'll either be marked as live or answered live, or will be answered in the Q&A directly. Cool. So just to jump into it for an agenda, we have a few things we want to go through today. So just a kickoff of what we're doing now and some introductions. After that, we'll go through the additions to the Knime data applications, which includes the new refresh widget and how we can embed the data applications. We'll then go 30 minutes through Knime Edge. And then lastly, we'll have an open session with just a Q&A where we can talk to some of the product ownership. Cool. So just to start off with, anyone who doesn't know me, I'm the solution engineer here at Knime that supports the partner organization. So happy to put this webinar together and kind of get some of this content for everyone to see. From this point on, if anyone doesn't know me, feel free to reach out and I can help with kind of any additional questions or any kind of proof of concepts of anything you're looking for to see more details on here. Also, we have Christian Berkholt and Jason Tyler. So I'll let Jason Tyler introduce himself.
Hi, everyone. I'm Jason Tyler. I'm the cloud lead at Knime. In addition, I'm the product owner for Knime Edge. So looking forward to being on the session today and going through Edge, answering questions, and yep, happy to be here.
Cool. And Christian?
Hello, I used to be Christian Dietz, but now I'm Christian Burkhardt. I got married some weeks ago, in case you wonder. I'm running product management at Knime, and basically I'm here to answer your questions regarding roadmap, how data apps, Edge, and other things fit into the bigger picture if you're interested.
Cool. Thank you guys very much. So we'll jump straight into data apps now. So with the update to the Knime data app, so data app is going to be any application that we're going to put on the web portal. So any of the applications that you build using components with composite views, just in case the name may be different. So what we did with 4.13, the rest of 4.13 is 2 enhancements to these data applications that are going to create a lot more use case for these applications. The first one is going to be this refresh button widget, which is a new widget inside of these views that is going to allow you to rerun these components. So essentially leading to more dynamic applications. I have a few examples I'll show. Also, we have the ability to extend your data applications to a public audience with embedded data apps. And this is going to be really powerful for larger corporations and larger customers, people that really want to kind of show off what they're doing with the tool, any kind of findings they are willing to make public or even internally public. So I can show some details of that too. So to start off with how the refresh button works. So this is going to enhance these composite views or the component views to be more dynamic and allow you to have more control over changing what's happening. So prior to the refresh button widget, you would likely have to have multiple different components with one page being maybe configuration, which then can pass to the next component for visualizations and things. With this new node, it's going to be a lot easier to keep them in one single page application. But on top of that, it also supports the hybrid approach too. So we can have certain components with a more dynamic view with the refresh capabilities that can also still pass to other pages. So it's not limited to a single page, but you can enhance the particular pages. Yeah, so That's all possible with the refresh button node. I can show some details of that. On a technical standpoint, for the partners that are possibly going to be implementing something like this, so what it's doing is it's introducing a flow variable into the component. And when you execute the button, so the refresh button, it's going to essentially rerun all of the downstream nodes that are connected to that, or that have that flow variable inside of it. So it's also okay to have multiple refresh button widgets, so you can have different kind of refresh or submit buttons that will rerun different parts of the component. So this is really helpful, especially if you're trying to use Knime to make more kind of data kind of update applications, or even kind of more like form applications with submit fields and things like that. And then on the last point, you can start to use these for even having more of a wizard application within your data application. So if I want to walk someone through a process, it's a lot more easy with these refresh and submit buttons. The second big update is going to be what I mentioned before, these embedded data apps. And these are really interesting. This is a really good way to kind of expose your applications. So this is only available for server large customers because it's essentially opening up and giving the application to unlimited consumers. So what happens is we have the ability to now share your applications. So there's two ways you can either give a login link or a non-login link. So with the login link, obviously, it's only going to be people that are created as users, either through your authentication system or through the built-in database on the server. But what we can do is actually create these authorization tokens for these non-login links, which will allow you to send just access to that workflow page. And this is really powerful, if we want to maybe embed it in a website. It's very easy to embed into an iframe, for example, an HTML code, or even just giving the link to particular people. So who is this for? Definitely server large customers is the only ones it's available for, and anyone who wants to share this, right? So at this point, if you make these non-login links, anyone who's available to hit that link will be able to run the workflow or to see the output of the workflow. So I'll show you in a bit how it's done. We definitely put a lot of guardrails on it to make sure no one accidentally does this. But as for use cases, this would be really powerful for like large corporations that have maybe they want this broad corporate access on an internal website, where maybe this could be a simple metrics board if you want to. It could be a way to submit data into a system, for example, or just kind of show something interesting, show some stats about the business that you want to see. And in that case, it's more of a networking problem to see who is available to get to that site. Also, if you want to just kind of show off your data science capability of a certain team, you can also embed these visualizations and applications into blog posts, websites, and things like that. So for how to do it, it's pretty simple. So when there's a configuration setting on the server called workflow authentication users, by default, there's no one in this group at all. So that's one of the guardrails. Even the admins won't be added to this list. You have to manually go in and add specific users to this group to allow them to be able to create these links. And then from there, you'll see here, you have the share icon. When you're looking at a web portal application, and only people that are in this authentication users will have the ability to create these links. And then you have the ability to create just a hard link or an embed code. So this would be more HTML suited link. You can just link it wherever you want to. From there, when they create the link, it's essentially creating a workflow access token that will only be, it only gives access to that particular workflow. And then also, if you can create multiple access tokens for different use cases, for example, and you can monitor those from the monitoring tab. So cool, let me go ahead and show you some of this in action. So as you can see here, I have a few different examples I'm going to go through, but inside these components, you can see that we have this now refresh button widget that will kind of start off the process here. And this first example that I'm going to show is how to now do cascading dialogues within Knime, which is a cool new functionality thanks to the refresh button widget. And you'll see here, so we have the case switch, which will go through these different options that I'm choosing between the selection widget. And as I choose different selections, in that dialog and hit refresh, it will then take me to the appropriate route within this component. So to show you what this looks like on the web portal. So here's one example where I want to select a different visualization. And just to show you it in action, I can choose a different choice and hit switch view, and it will go through the appropriate route within the component. So this would be just a text view, for example. I can go back to the original to do a bar graph. Ignore this. This is just, that's intentional. One second. I logged in as the wrong user, sorry. Cool. So here's the example of how to do the cascading dialogue. So if I run this one, you'll see within that component, there's a table view at the end of the component, and this is to kind of show how the entire thing is being rerun. So at the bottom, at the end of the component, we have this table view showing you the selections. This top branch would say I'm going to skip the first option, so it'll just give me null for the choices, and then the choices will cascade and get deeper. So as I go in, I have a third choice, for example. So let's go back to here. So for instance, I have skip, so I'll get skip and then null, no. If I want to go with option 1, oops, sorry. Hit the wrong button. So if I do option 1 and hit submit, now I have an option for choice 2, which is based on option 1, right? So then option 1B, hit submit again, and now I can go into the options that are dependent on option 1B. And you'll see that this is now being amended at the bottom here. If I go back to skip at the top, I can kind of revert my decisions. And this is just one component view. So from there, I can go into the next component if I want to, or the next page. So that makes this really powerful. So that's through the refresh widget. I want to get a lot of time for Knime Edge, so I'm going to just jump into embedded data applications now. So to start off how it works, so if we go into the configuration here, you'll see the workflow authentication users. This is me right now, so I'm the only person on the server who's allowed to make these tokens. And you'll see here, if I go to monitoring to access tokens, these are the tokens I've created. And it shows who created them, what type of link it is, an ID for it also. And just to show you, so I'm going to log in as a base user, just to show how it's not possible with them. So if I go into demos and kind of any of these applications, if I go into shared here, they won't have any access to make these tokens either way, right? So they can create a regular link, but with that link, you'll still need to log in. So if I sign out and log myself in as one of the people who's allowed to do this, I can now create these links either way. So the embedded with HTML or the link. So I'll just create this link. And you'll see here now, you have the ability to kill the access token. So if you're maybe accidentally, there's more people coming into this application than intentional, you do have the ability to maintain and delete these or create new ones for different endpoints. So I'll take this link and just to kind of show you this in action, I'll open an incognito browser and run it. So you'll see here now when I run it from that non-login link, so this would be the public link, but there's no other access to the server except for this application. So they can, do the same, they have the same controls, things like that. So it's the same application, but just without any other server functionality. So no dashboard, or none of the tabs are available, just the application. So cool. So that is the updates to the data apps, between the refresh widget and this new ability to embed the applications. I think opens a lot of opportunities and a lot of use cases, definitely for the data applications. Cool. So for the second section, we're gonna spend the next kind of 30 minutes going through Knime Edge and some of the good use cases here. I know I've had a lot of questions from partners just regarding use cases and when it's appropriate and things like that. So hopefully in this section or in this session, we can go through and address a lot of those. And also, once again, if you have any questions, please put them in the Q&A. We have all three of us keeping an eye on that. So to start off with, this, I'm sure some of you guys have seen this slide before about kind of Knime's philosophy of the data science lifecycle and how it's more of a continuous process where we have kind of one side being more the creation and ideation of the models and the use cases, whereas the right side would be more production and actually, using what we created in production and, giving some business value to it. So on the left side, we address it more with the analytics platform where we can do more of the exploratory data science, visualization, creating models. Where on the right side, we're going to have the Knime server mostly, right? Where we're going to, upload our production workflows, create applications, and kind of keep an eye on our models and model drift, for example. But one thing we definitely want to iterate here is, Edge is not a replacement for Knime server. It's an addition to the Knime server. And where Edge is really going to shine and for use cases is going to be in this kind of consumption and interaction portion of production. Also, when it comes into, literally Edge deployments on different regional edges. So if we go more into detail with that, the big use case I think for Edge is going to be this inference on demand. So when we talk about inference deployments, that's going to be akin to the API workflows you make where you're going to use a model that you've created. So basically it's an application of a model. So in this case, we would have two steps where one workflow may be doing the heavy lifting and creating the model. That would probably be a longer running workflow. And then on the side, you'd have a more lightweight model that's just used for inferencing or, letting untested data kind of be analyzed by the model and get a target or an answer and give it back to whatever application needs it. So with Knime Edge, that's the main point is for these inference deployments and how to, with a more scalable approach, make sure that they are working properly and can handle a high load. So in this case, a lot of the use cases are, if this inference workflow is being deployed to a lot of end users, if you're seeing a lot of maybe unpredictable spikes in demand, maybe for like some kind of website application, you don't know when you might have more traffic. If latency is an issue, right? So if we need to be closer to the machines, like in a kind of IoT setting, that's another important use case here. Geographical regions is also important. And that's a really important point here because a lot of people have been asking me the difference between an edge cluster and an executor. And the way that I think we have been describing it is, if we can have your Knime server and your distributed executors, that's kind of treated more as a central location where you're maybe creating the models with different data. From there, you can use that centralized Knime server environment to push these inference workflows to different regional areas where you have different edge clusters. So if I have a global website, I probably want to push these inference workflows to the actual locations like Sydney, for example, or UK, for example. We don't want every single call coming to our centralized IT environment. Yeah. So that's an example of what these inference workflows look like. So anyone who has worked with our API nodes and the container nodes, this probably looks pretty familiar. So this is going to be an example for sentiment analysis where we have container input on the left here, where we're waiting for these API requests and for the information. And from there, I'll just go through the workflow as usual. So in this case, we're going to take in these model readers and bring in the models and apply them to the data. And this would be a pretty low cost operation, right? So typically the creation of these models is going to be the heavy part of the process. But once we have the models ready, we can then just use them in this workflow pretty quickly. So that's why these inference, we want them to be scalable. Sometimes we're seeing hundreds of them come in per minute. And that's one of the main use cases here. So these next two slides are two examples that we like to show of kind of big POCs that kind of helped frame this. The first one's going to be an edge deployment for manufacturing. So this first one is going to be dealing with pushing a machine learning approach and project to a factory floor. So in this case, maybe we have the factories are typically a pretty isolated environment. They probably don't have too much networking outside the factory. So in this case, you want to actually take the model and bring it to the factory. And instead of having an entire Knime server install on each factory you have, in this case, you can have that centralized Knime server and pass them to pass the models to the different factories for them to use. And then from there, the Knime server in its centralized location can then be in charge of updating the models, making them up to date, and passing the new ones to the factories and replacing them. Another example would be, one more point. Another point on this manufacturing scenario is with these factories, sometimes the connection may get lost between the centralized IT location and the actual factory network. So another really cool part of Knime Edge is they're self-sufficient. So the Knime server can push these new models to the edge cluster, but if this connection gets broken, the edge cluster will still function. So that's an important part. So there's not a single point of failure there. Another use case is going to be for application services. So this one's kind of a different side of the use case where we're dealing with really high throughput. And you want to be able to scale this out and make sure that your application can handle how many hits are coming into the model invocation. So here we can scale to meet demand, especially when we're dealing with strict SLAs. The scalability is going to be really important here. And then also with deployment, as I said before, we can utilize different cloud geographical regions. So like for the website example before, we may want one of these edge clusters in every single geographical location where we have web servers, just to make sure that the latency isn't getting bad by asking the centralized location for invocation data every single time it needs an answer. Cool. So I guess for these next two slides, Jason, if you want to speak a little bit onto how these API endpoints are being consumed and how they're working.
Sure thing. And we'll get more into the kind of high level to mid-level architecture for how Edge looks like in a bit, but we can start by saying that Edge is very container oriented. It's actually built to be deployed as a Helm chart on top of a Kubernetes cluster. That could be a full-blown cluster of multiple nodes on any provider. For example, AWS has EKS or Azure has AKS. It could be a Kubernetes cluster on-prem. We even have it deployed in a demo that we're going to show in a bit. It's set up this way that we're using K3S, which is a micro Kubernetes distribution that can run on a single machine. So just because you hear Kubernetes, if you're not overly familiar with the platform, it is what we've built Edge on top of, and a lot of the reason for that is lifecycle additions that are built into the platform for how to handle scaling, for how to handle failure, for how to handle operational aspects. It gives us a lot of tools and flexibility to add the stability and scalability that we're looking for. In the context of this slide, kind of what we're looking at, and again, to reiterate, Edge is kind of treated as an extension to Knime server, meaning we still leverage Knime server, and we really leverage it as the control plane of the system. So you can have one edge cluster or multiple edge clusters all connecting into a Knime server, and they're essentially asking it, the Knime server, what do I need to be doing? What do I need to deploy? And again, as Stephen mentioned, the primary focus would be for moving models, moving inference-based workflows closer to where the data is actually being generated. And so this slide is to say that even though we're in this kind of Kubernetes cluster for where Edge is running, that once you're inside your network, whether it's in a cloud network or maybe in a factory or an on-prem network, you still have multiple access options for how you would connect or get inferences from an edge. It's all REST API driven at the end of the day. So every model, every workflow that you push from server down to an edge cluster is accessible via a REST API call, where you can pass a payload in and get an immediate response back. And that entire, from the request to the response, is the whole execution of that inference workflow. And so that could be consumed, as shown on the left side, internally within the cluster if you had other workflows inside that Kubernetes cluster, or we also build in external ingress or access capabilities. So just being on the same network where that machine or that cluster is, you still can make calls against the cluster and pull the inferences back that way. So again, if you're in an IoT scenario, something like that, you would have API access local in that network to make those calls.
Cool, thank you.
And then to kind of build on that, what this kind of looks like, there's a concept in Kubernetes of ingress, which is basically how we route requests, but it's probably easier to talk about it in terms of we essentially onboard an API gateway, and that's where we turn on external access. So even though we're in this cluster, we do have an API gateway endpoint. And so if you deploy one inference workflow or 10 inference workflows, they're all accessible from that single gateway endpoint, just on different REST paths. So each workflow that you deploy is a unique path on that API, but there's only a single DNS entry or IP that you would be calling to actually invoke those.
Cool, thank you so much, Jason. So now we'll jump into it, and we'll go and spend the next 20-ish minutes on a demo of how this would look to a customer, kind of once it's set up. And then this will be a two-part demo. The first part will just show the basics of how it works, and then we'll try to put it in action and put some strain on it to show you what that looks like. Sorry, 1 second. So when you have an edge cluster set up, or multiple edge clusters set up from your server environment, you still are going to interact with it from the server. So in this case, you'll see here I have this edge group of workflows, and this is something that every edge customer will have installed on their server. And from there, you can see we have different ways to interact with the edge clusters, send workflows to them, etc. So if I go to apps here, this is going to be the main way to deal with these edge environments. And this is important for the next few things I'm going to show, because I've gotten a few questions from partners saying, like, do I need to hire a Kubernetes developer or a Kubernetes admin? But most of these steps, once it's set up, will be done from Knime and using workflows. So example here, if I want to look into my deployments, which would be me passing these workflow applications to the edge cluster, I have different ways to interact with them here. I can delete them, update them. So if my model is changing, I want to update it frequently. I can look into the deployments and how I set them up, and etc. And then images would be kind of how these pods are being created on the cluster. So for instance, if I just want to start off by looking at my deployments, I can run into this, and you'll see here, so now I have 4 different edge clusters. So this could be in different locations also. So this could be, North Virginia, Sydney, for example, or different data centers wherever you want them to be. As long as that these two can talk to each other, you can put these edge locations wherever you want to. And let's say I want to look into this particular cluster. I get into more statistics on what's happening. And so right now I only have one application on it. It's going to be this fraud inferencer I could show in a second. But you can see the details of how it was created and all these configurable aspects to how we want this deployment to work with the amount of the minimum and maximum amount of instances for scalability. This one's pretty lightweight, but I think Jason has a more heavy one. But yeah, so if I go back to my applications. So when we have an edge deployment that's ready to go, and I'll show you what this looks like. Let me close these out real quick. So it's pretty interesting because this is also going to loop in the integrated deployment that we have as well. So this is going to be the inferencing workflow I'm going to send, right? So all it's going to do is bring in some information, do some manipulation, apply this random forest model that I created elsewhere on the server, and then return the results. I think it's the confidence interval and the prediction. But to look at the other side, which is what created this, we have this integrated deployment model creation step where we have data ingestion, and then these capture workflow sections, which are going to grab the pieces that are going to be akin to the call as well, stitch them together and create that deployed workflow. From there, I can take this inferencing workflow and pass it to an edge cluster where it will basically be live and waiting for responses. At that point, the edge is going to be what is able to kind of expand it and scale it out as we start to get more hits to this, right? So if we're starting to get hundreds and thousands of hits to this workflow, it'll start to scale a lot more cleanly. So if I go back here, I can go into create edge deployment. And this is going to be the kind of wizard that's going to help you go through the process of how to pass these to the edge cluster. So you'll see here, I'll just give it a name, a description. I'll say example. On there, you would pick whatever workflow you want to push. So in this case, you would want to push one of them that has that example. So the inferencing style of workflow where it has a container input and a container output. So I'll choose that one. And then at the bottom, you'll see more information about how we want to push it and what details. So what's interesting is I can push it to multiple edge clusters at the same time. So in this case, I have these 4. I can choose which locations I want to push this application to, right? So if we have different edge clusters for different purposes, like the website, for example, or factories, we can have much more control over which ones go to which location. And then this is going to be more Kubernetes information about, the minimum amount of pods, the maximum amount after scaling, the CPU utilization threshold that will kick off a new pod being created, and then kind of more specs of how much resources that pod is going to take on the machine that it's on. So you can get very specific here. This is going to pass all the information to Kubernetes, and that will all be taken care of just by running this workflow. So then from here, if I go to Lens, I can look into my environment, and you can see kind of the overview of the cluster, the pods that are alive, and the deployments I have. So you'll see here, if I go to deployments, this is that fraud inferencer that I sent it. These other ones are more kind of out of the box that handle internal processes within the cluster. But this fraud inferencer is the one that I sent. And you can see from there, if I go into pods, you'll see I have one fraud inferencer that was associated with that deployment. So from here, as that deployment or as that endpoint starts to get hit a whole lot, this will be what scales out and makes maybe more copies of the inferencer. So just to show it in action, if I go to Postman, this would be how you would interact with the server. So this is just hitting the just straight URL of where that Kubernetes cluster is. And if I hit that request, you'll get a response of the different deployments that are available on that cluster and the endpoint you would hit to kind of help you out. So in this case, I'm just doing a GET request just to see the information of what's available on that cluster. And this is the only one I have at the moment, is that fraud inferencer, which I just showed. So then if I want to interact with that further, I can pull in this other one. And you'll see here, this is going to be a post request to that inference location with the input to that container input in the node. So you'll see here in this case, I'm sending in one row of data. It's, pretty large, pretty wide column or pretty wide row. I'll send that in as the body to this location. And when I send it, I will get this response back. So I get the kind of the schema definition of the table coming back, and also the actual data for that row responded. So in this case, it becomes, like I said, a more lightweight way to use these workflows and interact with them. So it's just kind of sending one row in the situation. But as you start dealing with a lot of data and a lot of sessions and users, you can start to see where the scalability will come into it. And I guess from that point, I'll pass it over to Jason to kind of show what that part would look like, more on the monitoring and scalability of the system.
Yep, sounds good. Let me pull the screen up. Okay, and as I'm going through a bit of the scaling, we can touch on architecture a bit as well. So just to lay some groundwork for kind of what's going on this part of the demo. Again, I've set up a single EC2 instance in AWS. So, and I bootstrapped this whole instance in probably about 10 minutes. Again, it's running this K3s micro distribution of Kubernetes, which is open source from Rancher. I will mention Kubernetes. I know there's going to be differing levels of familiarness from participants, but I do want to make a strong statement that we do not have an expectation that everyone is going to be a Kubernetes expert, nor we're prepared and have documentation to walk through the process. There's a packaging tool called Helm for Kubernetes, which lets you bootstrap the entire edge cluster effectively with a single command and config file. So just by having a couple of CLI tools installed on that machine, you can bootstrap the entire edge product into the cluster with just that one config file and that one Helm chart. So kind of what this looks like, and we'll again briefly touch on the architecture. This is a beta documentation server. The plan is that Edge will go GA in approximately 3 weeks in line with our fall data talks. So all this documentation will be moved into a public space at that point. But I do want to kind of call out the separation here. So again, we're using Knime as the control plane. And one thing you noticed as Steven's walking through the demo is that all of the interaction points for the user are effectively web portal, so workflows. And that's very deliberate. One thing that we want to do with this product, being a newer product, is we want to have a very high velocity on how quickly we can add features and changes and push those to consumers. And so in this instance, by us leveraging web portal for both the UI and for these kind of, there's a set of workflows that act as the API endpoints that Edge talks to on server. The upgrade mechanic or the delivery mechanic is really just to push a new set of workflows to your Knime server, not to have to upgrade your Knime server. So there's no actual, Edge has 0 code changes to the existing Knime server. All of the control plane sits on top of it and is actually built via a set of workflows. On the Kubernetes side, are a number of pieces in here, and I don't think we need to go too deep into those since that's probably more geared for a technical discussion. But of note is there's one controller called the server adapter. It's the piece that actually talks to the server and pulls down a state definition of what it needs to deploy. And then there's a piece called the operator that actually handles all the operational tasks to manage everything inside of the cluster at that point. Again, what our goal to build here is really a distributed and decoupled platform where we can execute Knime workflows, especially built for inferencing, away from the Knime server. Again, this could be in a factory setting. This is pushing the model closer to the data. This could be pushing it to other cloud regions. And the idea there is that even if you lose connection to the server, this cluster keeps running and doing what it's currently set up to do. So we're trying to mitigate single points of failure and really offer a high level of scaling. So to show kind of what that looks like, I have a different workflow prepared. And so I'm in the same environment Stephen is in, and I'm going to create a deployment real quick. And this is going to be for a different cluster. And this is another demo workflow we have available that's a sentiment predictor. In fact, you can find it on Knime Hub just by looking for sentiment predictor. And this is a model trained off, I believe, airline reviews of sorts. And you'll see one thing that was kind of evident in what Stephen showed in the Postman example is that we can leverage input and output nodes. So in this case, a JSON input node and a JSON output node to tie in that REST API request so that we're feeding JSON in and we're getting JSON back. But we are doing a complete execution of the workflow inside of that request, inside of that time span. And so, there's patterns that exist here that we have documented and examples to show, but there is less overhead here than what you would see on the existing Knime server, meaning in Edge. So if you're familiar with the server architecture, normally if you make an API call to the server, it goes to the front end Tomcat, and then it goes on to a queue, and then it gets picked up by an executor. It gets executed, goes back on the queue. There's that's roughly what the round trip looks like. Here, the container itself is a fully encapsulated REST API directly wrapped around the workflow execution. So we've stripped a lot of the boilerplate off and try to make the API as simple and clean as possible. And this is why you can just literally post your request body and just get back your output without the additional overhead that you would typically have for the Knime server. So again, it's geared for consumption for production cases of where the model's deployed, and you just need to be able to start invoking it. So using this workflow, I'm going to give it a name. The description doesn't matter too much. I have one here, this sentiment predictor. Again, these images are just Docker images. These are runtimes for the inference agent, which essentially is very similar to an executor. It has all of the extensions, all those pieces, but you can have different ones if you need different configurations, different sets of extensions, etc. So I'm going to click one here. I'm going to actually deploy to this other edge cluster I've stood up. Notice you can actually deploy to multiple clusters at once. So again, if you're running clusters geographically dispersed, you could actually apply a model to all of them in one operation. I could also affect the logging level. Again, we have some scaling metrics down here. So for this, I'm going to say, let's start with 2 and say we can go up to 6 or 7. And that I actually want to scale out whenever the average CPU utilization is crossing 75%. And then I can also feed in min and max memory and CPU allocations. The CPU is actually milli-CPU. So 1000 is just 1 CPU core, 2000 is 2 CPU core, but you can be more granular if you would like. So we'll click close there. I also have my environment pulled up in this kind of lens GUI. And what we should see is within a couple of seconds, we've already pulled, see that there's been work assigned, and these two sentiment containers are already coming online. We'll give them a couple of seconds to go into a healthy state, and then we'll turn on our load test and kind of look at what that entails. But again, the scaling pieces, all these pieces are being controlled by this operator piece, which is really the brains of the cluster. And so these are already in a green state. In fact, if we just double check on Postman, I can do a get call to the root and see, okay, my sentiment is deployed, and I can do a sanity check real quick to make sure I can make a request against it. So I know, because we built the workflow, what the expected input looks like. And we can see, okay, that looks good. And you see a very short response time, but that is a complete execution. Likewise, you can flip this to a different input, but for the sake of the demo, we already have a load test prepared. So we'll turn this on, and this is basically going to start up a number of threads and slowly ramp them up. So the throughput should be just ever increasing over time. And so we'll let this kind of build up for a second and kind of watch it as it comes up. There's another view in here where we do have, and so again, I mentioned Helm. We have a registry where we host all of our Docker images and Helm charts. So for Edge, there's actually two Helm charts that are available. One is for Edge itself, the operator, and there's another one that is a Grafana-based metrics dashboard that kind of supports this. Again, the metrics is probably more if you're a little bit more familiar with the environment. I have it deployed here so we can take a look at it as data starts to come across, and we can get real-time dashboards on throughput, on error counts, etc. This is currently behind a layer of authentication. It's tied to a Knime.com user. That will likely change once we flip and go GA. But if you do have interest in the near term, in the next few weeks, to actually start looking at these things, whether it's through the beta documentation or looking at these charts, you just need to reach out to Knime, and we can open up access to you to be able to start looking at these assets. Let's see, let's go back and we'll see already, if we look at our pod autoscaler, we have a pretty high level of CPU over those two containers we deployed initially. So here the operator and the cluster is doing its job. It's already started scaling out. So now we have 1, 2, 3, 4 running, 5 running, we're up to 6. So all of this happened automatically. If we go back and look at our load test, we'll see we've already sent 3,000 requests to it just in the time I've been talking. Our throughput continues to uptick as those other pods come online. You can see that our average response time is going to continue to drop as we balance out the load here. There's some nice tricks that we've done in Edge that weren't really possible to do in the server architecture. So for example, having the ability to horizontally scale the containers that are doing inferencing, we can also implement, and we have here approaches like doing least connections as a routing mechanism. So if one container gets under more load than the others, the infrastructure is smart enough to realize that and will actually drive requests to the ones that are less busy and have less active connections. Likewise, if any of those containers dies, requests will be automatically re-forwarded to a healthy pod, and the client that's making the request doesn't even know. So there's a lot of hardness and durability built into this. And again, this load is all happening on this cluster. So none of this is affecting the uptime or utilization of the Knime server. And so if we look through here, we see we're continuing to increase our throughput. Just this one example, which is running on a single machine, we've already crossed over 2,000 requests per minute. We have engagements with other customers that are in a beta cycle that are able to achieve with stability, with no errors, upwards of 300 requests per second. So again, there's a large focus on driving a high level of throughput and being able to dynamically scale within these edge clusters to absorb that load.
Cool. Hey, Jason, I think we're getting a little short on time.
Most of what I had prepared. I guess in lieu of going over anything else, we can start going through Steve, unless you have something else, we can start going through the questions and taking
Yeah, I
them one
think
at a
for
time.
the remainder of the time, we have quite a few questions, especially regarding what you were just showing.
Okay. One thing I think that is useful to mention real quick, and sorry, this is pretty useful. So there are, again, a number of workflows here. So, and again, what we don't want, and let's use the example of you have Edge deployed into a factory setting or something like that. We don't want the normal user to have any working knowledge of that Edge cluster, of that environment. And so there are pieces here, and there are pieces that will be in the next release that are always improving the metrics and visibility from the Knime server point of view. So for example, if I wanted to actually retrieve logs for the workflow that I just deployed, there's a supporting workflow for that. And I can actually go and select the Edge instance I want to pull logs from. I can say the deployment that I want to pull logs from. I can give it a time window. We'll back this up a little bit. And then I can hit go. And from web server, I've actually generated a request for logs from that Edge instance. And so now the Edge instance is actually going across all of those pods, aggregating the logs, and then it'll compile them into a zip, push it back up to server, and then you'd actually be able to click and download them here. It might not fully fulfill here just because I've only been running this cluster for about a minute, and it usually takes about a minute and a half for the logs to fully aggregate, but we'll let that run in the background. But it typically only takes about 20 seconds. And the precondition is just that the deployment's been running for a little bit, but you can fetch all of the logs. You can view different levels of status on what you have running, et cetera, without having to necessarily go to this dashboard. But it is here and available. So sorry, continue on with other questions, Stephen.
No worries. Thank you so much, Jason. That was an awesome demo. So a few questions related to Kubernetes. So the first one is kind of the URL management within these different inference endpoints. So this user is worried it might seem like a lot of maintenance to know the different URLs of where these inference locations are.
Mm-hmm.
I believe most of that's taken care of automatically, right?
Right. So again, because we put a gateway in front, all you really need to know is what the DNS entry for that gateway is going to be, and you can actually fetch the deployed endpoints just by calling that. And this is also configurable. You can actually turn this base level endpoint discovery on or off, because we do understand that some people might not want to make that publicly available, but by default, it's turned on, and you would be able to actively see the paths that are deployed here. These paths also are available from inside the workflow. There's a number of parameters that get fed in specific to the request that you can extract inside the workflow. So if you wanted to actually inspect a path to make some logic choice, or if you wanted to look at some metadata for the request itself, that is something there are patterns that exist inside the workflows to have access to that. Cool.
And then another question, which is I think really important, especially for the partners that are starting to look into these use cases, and it's dealing with the kind of installation activity that's going to be required from the partner. So like, I'm going to combine two questions here and just, kind of from the partner perspective, how aware do they have to be of what's going on in Kubernetes when it comes to troubleshooting, things like that. So when it comes to the Edge setup and the installation of the system, kind of just that entire area.
So I'll use beta docs to kind of frame this a little bit. Again, all this documentation will be kind of cleaned up and pushed into the public space soon, but we do have an integration with TensorFlow, for example. And I mean, if you were to walk through this, you'll see the exact steps needed to install on Linux. And it looks like a bunch, but this actually condenses down to just a few commands. Again, for those not familiar with Kubernetes too much, the K3s cluster, for example, that you can run on a single machine can be installed with a single command line. In fact, it looks like this. It's just a curl call that you run this command on an Ubuntu machine and you have a Kubernetes environment fully stood up. The packaging and templating tool that we use to actually bootstrap an edge cluster sits on top of that. It's called Helm. It's a Helm chart. It's probably the most widely used deployment option for packaging more complex applications. And again, it is a single configuration file. The configuration file looks like this. It's just a YAML file. There's maybe 5, 6, 7 values you need to update in here. And then there's a single Helm command that deploys the cluster. And at that point, this piece that I call the operator really takes over. So the goal is that from a user's point of view, there is little to no interaction with the cluster once it's actually installed, other than occasionally doing a Helm upgrade command with a new chart definition to upgrade the components. The operator pattern that we leverage is a very popular pattern emerging inside of the Kubernetes space, where you're essentially building a process that is it's an operations process. It is a process designed to handle all operational tasks. So if any of the components were to fall over, the operator corrects them. It always is trying to maintain the cluster in a known healthy state. And that is an active development piece that will continue to get hardened more and more over time. But if we look here, in addition to the sentiment predictor pieces, there's a number of supporting microservices here. Any one of these I could terminate right now and the system would stabilize itself within a few seconds. So again, all of the traditional operations knowledge that you would think you would need to have to maintain this environment is really built into the product itself. And we do have support and customer care on standby to help dive into any issues or questions further.
Mm-hmm. Cool, thank you so much. And we only have a couple more minutes. I think last question I can take is how do we position this to customers who don't have a global presence, where distributed execution seems more preferable? I'd say it's really dependent on what they're trying to do with the model and how they're trying to productionize the application here. If it's something that is going to be a high kind of throughput or invocation, that's one use case. Also, what this does is kind of moves the execution of the production environment away from the centralized server. So there's a lot of different areas where this could be useful, not just from a global distributed global setup environment. But so if you guys are interested, be happy to jump through like an ideation session. Just reach out to me or your partner manager. We can go through more details there. And considering, go ahead.
Yep, I mean, and just to add to that again, I don't think global presence is required to any level. This is really for if you've been using Knime server for a while. Again, I mean, this is a complement to it. We still envision Knime server and executors really for heavy, large workflows, ones that need a lot of CPU, a lot of RAM, ones that are training models, ones that still your users are connecting to from analytics platform for collaboration. Really the goal of Edge is, even if it's only getting deployed to 1 or 2 places, that you have a mechanism and a platform that you can push a lot of residual capacity to, so that Knime server can still be leveraged with a focus on model training and kind of collaboration without adding any risk or any basically, maybe the best way to say it is that Edge is designed for high availability and scalability. Server can just as easily do a lot of those same actions, but one thing that server has a bit more trouble is if you need to put like a HA proxy or something in front of it for failover. And so again, the idea for Edge is if you have mission critical processes and you do not want to incur the potential of downtime because you need to flip your server for maintenance or you lose network connection to it, something like that, that's where Edge really kind of comes into the picture.
Cool, thank you so much. And since we're kind of out of time, just in respect of everyone's time here, there's a couple more slides. The last thing, I'm just gonna some updates from the partner side. We have a few new things we've added to the partner portal, including these partner events. So keep an eye on there. So events like this, we're gonna have probably more often where it's exclusive for the partners. You'll find the registration information on the partner portal, and some more information also. In terms of more webinars coming up, we do have a Knime server administrator session, just to get you prepared for the exam. That's partner exclusive. I'll be running that. So if anyone's working on, the Knime Ready requirements to get that server administrator certification, that's a good way to prepare for it. Just reach out to me for any information. The registration's also on the partner portal. And then also we have the fall data talks coming up pretty soon. But cool. Thank you guys so much for attending today. I think it was a lot of good information for the partners. If anyone has any additional questions or kind of wants more information, feel free to reach out to me or your partner manager. But thank you so much.